So in this video, we're going to talk about gas evolution reactions, okay? And we're going to solve two problems on gas evolution reactions. But before we solve those problems on gas evolution reactions, let's take a look at what exactly is a gas evolution reaction. So a gas evolution reaction is a reaction where you have, let's say, two compounds. Let's say you have A reacting with compound B, and that ends up giving you a compound C plus, let's say, some other compound D, and C ends up being an unstable compound. So this can decompose to give you a gas. Okay. Another option is where C itself is a gas. Okay. So let's take a look at some examples. These are some of the scenarios you'll run into. And then once we understand those examples, we'll kind of take a look at this problem out here. So let's say you have two HCl reacting with, not 2HCl. HCl reacting with K2S. That gives you H2S, which is a gas, plus KCl. And you can balance the reaction. But right now, we're just trying to understand how to recognize a gas evolution reaction. So as you can see, this reaction looks very similar to what we did out here, where C was a gas itself. There it is, okay? Another scenario we can find out is if you take the same HCl and AQ, react that with K2CO3. Now it forms KCl plus H2CO3. And whenever you see this compound H2CO3, turns out this compound decomposes very quickly to form H2O plus CO2. CO2 is a gas, and that is an example of the first kind that we mentioned, where the C is unstable, it decomposes to give a gas. Very similar to this is if you had HCl reacting with K2SO3. So HCl reacting with K2SO3, and that gives us KCl plus H2SO3. And again, as you can see, H2SO3 looks very similar to H2CO3, with the difference being that here's it's sulfur instead of a carbon. And this one, again, is very unstable. It decomposes to give you H2O plus SO2, which is a gas. All right, that's the third type. So what did we see? We saw H2S as a gas forming, CO2 as a gas, SO2 as a gas. The last example we'll look at is where you have, let's say you have NH4Cl aqueous plus KOH. And then what it does is it forms H2O. You can switch the ions around. So the OH minus combines with the NH4 to form NH4OH plus KCl. It turns out NH4OH is very unstable, and so this decomposes to form NH3 gas plus H2O liquid. And that is the third type of gas that you will see. So, the fourth type of gas. So you have H2S, or you could have CO2, SO2, or NH3. The last three that we looked at were similar to the C being unstable, and so it decomposes to give a gas. While the first one, you have a gas readily formed. All right, so now that we took a look at these scenarios, let's try to solve this problem out here. I'm going to go ahead and remove all of this from the screen so we can focus on that problem. All right, so we have a reaction that takes place between aqueous hydrobromic acid, so that's HBr, aqueous, plus aqueous potassium sulfite, which is K2SO3. All right, so we have that reaction taking place out there. And what the question is asking us to write a molecular equation for this reaction. Okay, so to write a molecular equation, first of all, we need to understand what's the HBr, what kind of ions it's forming. So that's forming H plus and Br minus ions. And then the K2SO3 is forming Ka plus and SO3 2 minus ions. Now we can combine them. So we're going to do crisscross. So the H plus can combine with the SO3 to form H2SO3. And then the Br minus combines with the K plus to give you KBr aqueous. Now it turns out the H2SO3 is not very stable, so it decomposes. But before we draw the decomposition products, let's go ahead and balance the reaction. So to balance this reaction, we need to put a 2 out here and then a 2 out here. Okay, and that should balance it. Now let's go ahead and decompose the H2SO3. So that gives us H2O liquid plus SO2 gas. All right, now let's go ahead and rewrite this entire thing properly. So 2HBr plus K2SO3 gives us H2O liquid plus SO2 gas plus 2KBr aqueous. And that is your molecular equation. All right, I hope that made sense. Let's take a look at another problem. Out here in this problem, it's asking us to write the net ionic equation for a reaction that occurs when you mix hydroiodic acid with calcium sulfide. So hydroiodic acid is Hi and calcium sulfide is Cas. So let's go ahead and do the same thing that we did before. The ions that are going to form is H plus and I minus. And the ions out here are Ca2 plus and S2 minus. Now let's go ahead and crisscross the ions to give us possible products. So that's going to be H2S. That is actually a gas already. So that would be, so that gas is out here. And then the other one is going to be CaI2. Okay, let's go ahead and try to balance this reaction. So we need to have 2Hi out here. And that should do it. Okay. So now that we have that, what we've written out here is called the molecular equation. In order to get to the net ionic equation, we need to change the molecular to the complete ionic equation. So let's go ahead and write out the ions. So 2H plus 2I minus plus Ca2 plus S2 minus gives us H2S plus Ca2 plus 2I minus. All right, now let's go ahead and cancel out the common ions, the spectator ions. We took that out. And we have left 2H plus aqueous plus S2 minus aqueous gives us H2S gas, and that is your net ionic equation. Okay, I hope that made sense.